Thank you. These are the agendas which we will discuss throughout this presentation. Let's start. First, everywhere 1.35 million road deaths happened in a crash or fatal accidents because due to fatigue or any other medical stresses like drowsiness or cardiac events. So our project goal is to real-time health monitoring using pulse oximeter, SpO2 dash cams, and steering sensors, which is already adopted by few companies, but they are not doing it in once. They are doing it individually. So our project novelty is there. We are incorporating everything in one place. So our goal is low cost, automatic and user friendly system. For the motivation, there is a picture of a crash in a CCTV footage. You can see a car leads in a religious procession because the driver has his cardiac issue. And the WHO confirms 90% of road accidents happens because of fatigue or stress. So let's start the detection process. For first of all, heart rate detection. There is a problem introduced by our honorable coordinator sir when we were presenting back in our classes. We were using 88-32 module, but 3 electrodes has to be seated in the 3 chest points. So that can be very uncomfortable for drivers. Because nobody wants to wear something while they are driving. So what will be the solution? So after working this on this very insightful thought of our coordinators, we have discussed with our mentor sir and find a solution which is next 3000. Where mainly we are acquiring the BPM through that ECG signal, but next 3000 is giving the exact BPM. So we can really use those threshold points and use those threshold points to dictate the alert system which we are designing here. So for example, here we can see if the heart rate is less than 60 for large number of time, then it will show the bradycardia and it is not safe for driving. If it's between 60 to 100, then it is normal and safe. The driver can drive. And if it is greater than 100 for a large number of time, then the driver should not drive. So after that, we can see we have to take the data from finger here. We placed it on a steering wheel. Here, my friend Jiarul is covering the red light of that sensor, and that BPM directly shows into our app which we have built. My friend will discuss about the whole basic of the application, but my part was to send him this data. So I find the IP address and give him the link and rest him watch it on. After that, alcohol detection. For alcohol detection, again there is a problem to rectify. Our honorable coordinator sir told us where you will fit it and how this will affect. This will not affect the passengers, because in modern country alcohol consumption is legal in some countries. So what we do there? So for in that case, we have again contacted with our mentor sir and established a piloting logic behind it. So that is we decided to place it on the steering wheel as well because from there the driver is the nearest. So the alcohol concentration will mostly come from him, and also there is a problem because we use perfume. So perfume contains alcohol. So we have set the threshold point. Normally it is from. Normally it's on the 200, but we have set the threshold point in 1000 because which is 5 times more than the usual value, which will help us to extra gases and it will not affect the passengers alcohol because the sensor is far from the and sending data to the application of the process is same I discussed about in the BPM process. So that's all from my side. Now I would like to request my teammate to continue.
Thank you, ayan-jiya-gazi-mukut. Now I am explain about the two things that we use in our project. SPO monitoring by using the MAX 301 sensor and environmental monitoring by using the DST11 sensor. These two modules helps to ensure the driver health and cabin safety. First of all, what is SPO2? It measures the peripheral auxiliary oxygen saturation level in the blood. In our system, SPO2 monitor and heart rate measured by using the MAX 301 sensor. It is an integrated pulse oximeter and heart rate sensor. It uses two LEDs. One is red LEDs and IR LEDs to measure the oxygen saturation and BPM. This sensor communicate with the microcontroller using I2C protocol. This sensor continuously read the data and compare with the previous threshold level. At the end of this slide, we can see some threshold level such as 95% to 100% for the normal range, and below 94% it generate warning situation, and for below the 90% it will generate it is critical situation. Then the MAX 301 sensor work based on the photon plate seismography. Light passes through the fingertip. Oxygenated hemoglobin absorb more IR light, and deoxygenated hemoglobin absorb more red light. So by calculating the ratio of absorbed light, we can the sensor determine the SPO2 value. Here we can see the code for detect the SPO2 value. Here we use the function that is POX.get SPO2, which is measure the SPO2 value and show to the display section. And then the environmental monitoring by using the DHT11 sensor. This sensor measure temperature and humidity. High temperature can causes driver fatigue, and high humidity can causes driver discomfort. So this system can supporting the overall driver safety. After that, the way of DHT11 sensor working. Here, basically for the humidity measurement, it uses a humidity capacity sensor. When the humidity changes, capacity also changes. And for the temperature measurement, it uses a NTC thermistor. When the temperature changes, the resistor also changes. And next is the code for the detecting humidity and the temperature. Firstly, here we initialize the display section. Here we initialize the DHT11 sensor and the OLED display, and then we configure the pin and DHT11 sensor tag. After that, we read the temperature and humidity by using this function, and then we show the temperature and humidity in the display section. Now I would like to request my teammate to continue from there.
Thank you, Jerusalem. I am Gazi here. I is 21029. Driver, my part is driver drowsiness detection system. Drowsy driver is the most dangerous and hidden cause in road accident. if we can detect drowsiness, we can reduce road accidents, and we can reduce road accident and save some lives. And drowsy driver, for drowsy driver, depends on some factor. It's like a physical factor and environmental factor and lifestyle. When driver is drowsy, when he drives, he cannot recognize the road properly, and he also he cannot recognize properly. As a result, that vehicle can be accident this time. After few days our big festival is coming, and here we all are trying to go home with our family to make this festival more enjoyable. But will we home safe richly? We cannot say this because we can be affected in this accident also. Our project is solution to give this problem. Our project mainly identifies the driver drowsy or not. If the driver is drowsy, then it gets an alarm so that driver can brake instantly and save some from accidents. And for our making our project, we use hardware and both. In hardware section, we use USB camera, ESP32 and buzzer. In software section, we use these types of things. In our working flow, we use camera for capturing image, and we use media for detecting the eye ratio, and using NumPy for calculating these things. And this is our project, and we set a threshold here 0.22 and our ER ratio 0.29. Actually, that is not actually drowsy. If our ER ratio 0.22 and threshold 0.22, but ER ratio 0.19, this is the below the threshold and detect drowsiness. I want to see our project video here. And I would like to request ayan-jiya-gazi-mukut.
Thank you, Gaji. Assalamualaikum everyone. I am ayan-jiya-gazi-mukut. My ID is 021221006. For our project, we have developed a web-based application that monitors the driver's health condition in real time. The main goal of our project is to improve road safety and reduce accidents that may occur due to driver's problems. Many accidents can happen due to driver's problem because drivers become drowsy, stressed, or physically unwell while driving. Sometimes drivers may have an abnormal heart rate, may feel sleepy, or may even drive after consuming alcohol. Our system tries to detect this problem earlier and provides an alert. In our application, these monitors. In our application, this monitors three important parameters. The first one is heart rate monitoring. For the heart rate monitoring, our system measures it in beats per minute, also known as BPM. If the heart rate is between 60 to 100, then this is considered as normal condition, and And if the level is, then in our application, this will show that the driver health is normal and it is easy to drive. And if the value is less than 60, then it will detect bradycardia, and the application will pop a notification that the driver is having bradycardia and he is not safe to drive. And same as was for the tachycardia. And the next is our drowsiness monitoring. In our hardware, there is a camera, and if a driver is driving and his eyes is closed for at least 1.6 seconds, his ear ratio and eye ratio is if less than 0.22, then it will detect the driver is driving and notification will be popped up. The next is alcohol detection, and if there is a threshold point set in our code that if it crosses this level, then it will detect alcohol and our notification will be popped up. There is application demonstration. Here are some project outcome that we have covered in our project. This is the project timeline that we have followed throughout our capstone project. And in conclusion, I would like to say, by monitoring drivers' health monitor in real time and providing an early alert can prevent a lot of accidents and save lives. Thank you everyone. That's all from our side. We are Group 2 signing off.
for your presentation, nice presentation. I think due to time constraint, we will not be able to see the video. We'll see your project in the demonstration. So the floor is open for questions. Whoever's here, or you ask the question.
I think it's a good project. Can you go to slide 17? The picture of the city.
You can ask question to a specific student.
I think there is a picture of PCB. Not this one. I think it's slide number 17.
Next slide.
Was it down?
Yeah, this one. Yes. So I have, can you identify components in this PCB?
Sir, this is the IR and this is the radio.
There are different components, I guess. Which one is not? I can see there are a number of these components here.
Yes, sir.
The number of chip,
Yes, sir.
okay, then we will register or something.
Yes, sir.
Okay, so can you identify which one is which component?
I don't know, sir, because I can. For example,
Have you designed this PCB?
what is this thing?
No, it has buttons. Oh, okay. Okay, and yeah, still, I think you should be able to identify which one is this component, right? Not like you know,
সুইচ অফ থাকতে দিয়ে
you should be able to know it. For example, you have some connections at the bottom. So can you say that what is the connection of this connection?
Sir, this is the deep or supply voltage, and this is the serial flow data that we passes and serial flow like that. Yes, and this is the serial flow data that will passes from the master slave. Master that is the yes to microphone. And this is the interrupt pin that we did not use. And also, this is the IR drive, and this is the red light drive that is connected